Alright, so this is going to be a very quick demonstration of what I've been able to implement. This is a bidirectional reflectance distribution function as defined by the microfacet model, which models microfacets instead of just the surface as one big reflective plane. And with that you can model roughness. So right now I put the color on black so you can see the Fresnel effect, which makes the object at like when it just hits the surface, then it becomes mirror-like, even though it is not reflecting the light like at the entire material, entire surface. And here we can see what happens if we change the color. And if we put it all the way to white, we can see that it reflects now the environment at every angle. And we can also switch between different skyboxes, and this shows the reflectance as well as the diffuse or the irradiance. If we go all the way to roughness 1, which is this one over here, and you can see on the left, which are the different MIP levels, and these are pre-filtered environment maps, because this would be very computationally expensive to pre-compute or to compute every frame, because it is a normalized normal distribution function that gets sampled like hundreds of times for each light angle. That would be too computationally expensive, but by pre-computing it and storing it at each level of the MIP chain, we can save all this performance, calculate it once, and then reuse it every frame. And also we have a lookup texture here, which also stores a part of the equation, the brdf, and on the bottom we see the irradiance map, so that just calculates the light at a specific angle. So it's not the reflectance, but just the direct light that gets hit at a specific angle of the surface. So for example, here a ray will be shooting out in this direction instead of via the camera and then towards the scene. So that is the two parts that are relevant for this conductive material. So these are not dielectrics, this is all conductive or conductors, and you can see that the different MIP levels get generated for each skybox when we switch to that specific skybox. And here we can also see an environment with very pronounced colors. And if we go look at the changing the color of the material, this would be like a bluish tint. It tints the reflection as well, and here you can see also the blurring happening, and also the Fresnel effect at this when you're close to the surface, or like grazing angles is what they call them. You can see it especially when the material is black. And that's about it. I can also go create some other colors. And what is interesting is that right now it's one single color, but what we could do is create a diffuse map and a normal map and also a roughness map, and combining those enables you to already model or create like quite a realistic looking model, because it's because of these material properties that are able to model quite a wide range of materials. That's about it. That's what I wanted to showcase. It's quite boring, but I'm really happy that it works. This uses the implementation as defined by this paper over here. This paper by this person, and also the blog post of this guy, and Unreal Engine's shading model for like an older version of Unreal Engine. Yeah, that's about it. Thanks, and maybe next time I will have some more interesting things.